But those for longer direction, I'm going to start with the design of building. So for design of building, yesterday I've completed for the ASD calculations for the shorter span. Now today, ASD calculations for the longer span. So those who were not there in the yesterday's lecture, they can leave 3 to 4 pages and start with the ASD calculations for the longer directions. As we are going to design the slab, two-way slab. So we need to calculate the ASD for the shorter direction also and for the longer direction also. When we are going to design for the one-way slab, we have to calculate for only shorter direction. But for two-way slab, the ASD will be for the both the directions, that is for the shorter as well as for the longer. So first of all, you need to calculate the percentage, that is gamma Ty. So for calculation of gamma Ty, you are having the formula that is 50 into FCK by Fy in bracket 1 minus under root of 1 minus 4.6 mu upon BD square FCK. So as we are calculating for percentage, you need to multiply here by 50. So substitute all the values. FCK is nothing but the grade of the concrete. So the grade of the concrete is given to you, that is 20. And the Fy is nothing but the grade of the steel. So grade of the steel is given to you, that is 415. Then MUY is nothing but the movement that you had got in the earlier step. So substitute the value for movement, that is 10.49 into 10 raised to power 6 upon BD square FCK. So D for the longer direction comes up to be 140 and B comes up to be 1000 and FCK is 20. So after substituting all the values, आपको gamma Ty, that is percentage for the longer span, मिलता है 0.13153%. So do up till here. Those who were not there in the yesterday's lecture and those who were present in the yesterday's lecture, if they are completed, you can proceed with the ASD provided for the longer direction. And if you are having any of the doubts, you can ask. Yes, all the others had got the answer of this, that is 0.153. So you can proceed with the ASD for the longer direction. That will be 0.153 into B into D by 100. So ASD, you are going to get it as 214.20 mm square for the longer direction. After completing this much, let me know. Okay, done up till here. Everyone had completed. Is completed. Yes, everyone got the answer for the ASD, that is 214.20 mm square.
Yes, ma'am.
What about others? Should I proceed further? Yes, please reply in the chat box, or you can unmute yourself and you can speak. Okay. So after calculation of ASD, you need to calculate ASD minimum. So ASDY is greater than ASD minimum. Already in yesterday's sum, you had calculated ASD minimum. So ASD minimum आपको कितना मिला था? ASD minimum you had got, that is 204 mm square. That is 0.12% of B into capital D. So 0.12% of B is your 1000 and D is your 170. So ASD minimum you had got, that is 204 mm square. So as ASDY, that is ASD for the longer direction, is greater than ASD minimum, your design is okay. Now you have to use 8 millimeter diameter bars for the spacing. So you have to calculate the spacing over here, that is pi by 4 into d square upon ASD into 1000. तो spacing आपको मिलता है 234.66 mm. So calculate spacing. Okay, everyone had got the value for the spacing, that is 234.66 mm. So you have to take minimum spacing, round off it, that is 230 mm center to center. Yes, should I proceed further? Okay. So S is less than or equals to 300 mm or 3 into dy. Dy is nothing but the depth, effective depth for the longer direction, that we had got it as 140. So 3 into 140, that is 420 mm. So your spacing should be less than all these values. So already you had got the spacing, that is 230 mm center to center. So here your design is safe for the spacing. So you can provide 8 millimeter phi at the rate of 230 mm center to center for the longer direction. Now you need to calculate ASD provided. So for calculation of ASD provided, you are having the formula, that is pi by 4 into d square into 1000 upon spacing. So यहाँ पे diameter आपने कितना लिया है 8 mm का. So you have to substitute the value for the diameter, that is pi by 4 into 8 square into 1000 upon spacing. So you will get ASD provided, that is 218.54 mm square. So do up till here. And if you are having any of the doubts, you can ask. Yes, done up till here. Everybody had got the answer for ASD provided, that is
Yes, ma'am.
218.54. Okay. So this is the main reinforcement for the shorter and the longer span. Now we need to calculate the corner reinforcement. So anyone is having any doubts up till here? If you are having any query, you can ask. Proceeding for the next part. Hope everyone understood. Yes, clear? Yes, reply is mandatory to everyone. Now proceeding for the corner reinforcement. For corner reinforcement, you need to apply the torsional steel. So for torsional steel, as you know that the slab is your torsionally restrained, you have to apply the corner reinforcement as per the clause D 1.8 of the IS 456/2000. So according to that clause, you can provide the corner reinforcement at a distance of LEX by 5. Abhi L effective in X direction. So L effective in X direction आपको कितना मिला था? That is 4150. So substitute the value of L effective in the x direction, that is 4150 upon 5. So you will get it as 830 mm. So 830 mm in the both the directions in the meshes. You will provide the 830 mm in both the directions in the meshes at the top and the bottom layer. In all the 4 layers, you have to provide this one. So mesh you will provide it at a distance of 830 mm in both the directions for the top and the bottom for the 4 layers. So note down up till here for the corner reinforcement. So for corner reinforcement, you will provide it at a distance of 830 mm in both the directions. You have to provide the meshes for the top and the bottom in all the 4 layers. Your ideas will be more clear when we will do the detailing for this slab. Is completed up till here. Okay. All the others are also completed.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So area of the torsional steel. So area of the torsional steel, the formula to calculate the area of the torsional steel is 0.75 into area required for the maximum midspan movement. So the area required for the maximum midspan movement, that is maximum area you have to consider. So the maximum area is ASDX. So maximum area required for the midspan movement is your ASDX. So substitute here the value for the AXT in the X direction that you have calculated earlier. So आपको AST मिला था 265.80. So उसपे से आपको area of the torsional steel कितना मिलता है 199.35 mm. So calculate the area for the torsional steel. Area of the torsional steel will be 0.75 into ASTX. Substitute the value of AXTX, you will get the area for the torsional steel. Yes, everybody had got the value for the area for the torsional steel, that is 199.35. Yes, you had got the value for the area for the torsional steel.
Yes, ma'am.
Okay. So after calculating the area, you need to calculate the number of bars. So number of bars, how you are going to calculate? You are providing 8 millimeter diameter bar. So from that you can calculate the number of bars. So number of 8 millimeter bars, that is here ASD upon this 8 pi by 4 into d square, that is you are providing 8 millimeter 5 bars. So already you had calculated the ASD. So ASD for the torsional steel upon pi by 4 into d square, you will get the number of bars. So total number of bars that you have to provide on the corner side of your slab is 3.96. That will be approximately will be equals to 4. So you can provide 4 bars and all the bars is of U shape for both the ways in the top and the bottom. And on each corner you have to provide these bar at an area of 830 mm by 830 mm, because already you had calculated the distance of 830. So you have to take 830 only distance from both top as well as for the bottom. So understood up till here. If anyone is having any doubts, you can ask. So do up till here, then we shall proceed for the further step. Total number of bars you had got, that is 4. After completing up till here, let me know. Yes, done. Everybody had got the number of bars as 4. Should I proceed for the further step? Yes, done. Reply.
Done, ma'am.
Okay. Now you have to check for the deflection. You have to do the check for the deflection control. For checking the deflection, first of all, you need to calculate the percentage. So percentage provided you need to calculate. So percentage provided will be 100 into ATX provided. That is the area provided. So area provided upon B into dx. That is the effective depth in the x direction. So see, you had calculated all the values earlier. So ATX you had got, that is 270.826 in the previous step upon B, that is 1000, and effective depth in the x direction, that is for the shorter span you have considered it as 150, जो आपको पहले मिला था in the step number I think 3. You have got the dx percentage provided, that is 100 into ASD provided upon B into dx. So इसमें से आपको percentage provided मिलता है 0.18%. After calculating the percentage provided, you need to calculate Fs. Fs is nothing but the tensile stress. So for that, you are having the formula on your IS code page number 38. So for calculation of Fs,
Ma'am, your voice is breaking.
um, now am I audible? Now my voice is clear? So for
No, ma'am, still not audible.
calculation of Fs, now it's clear? 0.58 into,
Yes, ma'am, now clear.
okay. So Fs will be equals to 0.58 into Fy. Fy is nothing but 415 into ASD upon ASD provided. So ASD is your 265.80 upon ASD provided. So that is 270.826. इसमें से आपको Fs मिलता है 236.23 megapascal. So do up till here, do these calculations for percentage provided as well as for the tensile stress, that is Fs. Then we shall proceed further.
Ma'am, screen is not visible and your voice is breaking.
Wait. I will again share the screen. Now it's visible to you. Now my screen is visible.
No, ma'am.
Wait, it will come. After calculating the percentage provided and Fs, let me know. After completing up till here, let me know so that we can proceed further. Okay. All the others are also completed. Should I proceed further? Okay. So after calculation of Fs, you need to calculate modification factor. So modification factor, how you will get percentage, already you had calculated, that is 0.18%, and FS just now you had calculated. So from your I score, that is from figure number 4, refer your I score figure number 4 of your IS 456 2000. Modification factor you will get it as 1.6. परसेंटेज मिनिमम अगर आपका 0.18 है और एफएस आपका 236.23 है, so refer your figure number 4 of your IS code. You will get the modification factor as 1.6. So for 1.6 modification factor, you need to calculate L by D max. So first of all, see your IS code, figure number 4 for percentage 0.18 and FS 236.23, KT will be 1.6. Yes, everyone got the value? Okay, this is your figure number 4. यहाँ पे आपको FS कितना मिला था 236.23 and percentage provided you had got that is 0.18. So for 0.18 and for FS 236.23 modification factor you had got that is 1.6 something over here. यहाँ पे कहीं पे आएगा. So modification factor we are going to consider it as 1.6. See, the formula for FS is also given over here, that is 0.58 into Fy into area of cross section of the steel required upon provided. So done up till here. Should I proceed further? I think everyone had got the modification factor 1.6. So after that, L by D max. L by D max will be 1.6, that is modification factor into 20. Why we had multiplied it by 20? As we are going to consider simply supported slab, you have to multiply it by 20. So whenever we are going to consider for the simply supported slab, you have to take it as 20 only. So modification factor into 20 comes up to be 32. Then you need to calculate LEX upon DX provided. So LEX, that is effective length for the X direction, that is for the shorter span. So effective length is 4150 upon DX, that is effective depth. So effective depth आपको कितना मिला था 150. So considering this ratio, you will get it as 27.67. So your this ratio, that is LEX by DX provided, is less than L by D maximum ratio. That is the length by depth maximum is less than LEX by DX. So your design is safe over here. So you can assume the depth, that is the depth, whatever
Ma'am, you are
depth you
not
are.
audible.
last 1 minute is there. So those who are not given the attendance, give your attendance in the chat box and rejoin the lecture again after 10 minutes. So LEX by DX provided is less than L by D maximum. So whatever depth you had assumed is enough for to control the deflection. All of you give your attendance in the chat box. We are having less than a minute. And calculate this L by D ratio for maximum as well as for the provided. Yes, if you are having any doubts, you can ask.